All right, we're continuing to look at linear inequalities, specifically graphing them. And this corresponds to example 3 in your textbook, page 318. You got it, practice 3A and 3B. And if you'll notice one thing off the bat, in both of these inequalities, we do not have a y. We just have an x. And of course, when we go to our graphing calculator, it ordinarily is reading y equals. And this is where our new little app that I introduced to you in the previous video will help us. And we're going to get on the calculator here in just a moment. But first, let's take these inequality statements and let's isolate the x. So over here on the left, we got 4x minus 3 greater than or equal to 17. And so we're going to then add 3 to both sides. And this is going to leave us with 4x is greater than or equal to 20. 3's cancel over here. 17 plus 3 is 20. And we're going to divide both sides by 4 to where x is greater than or equal to 5. And of course, we want to jot this down for when we jump over to our calculator. In fact, let me jot it down right now. All right, now let's take this second inequality. You got negative 2x plus 6 is greater than 12. So let's subtract 6 from both sides initially. And it gives us negative 2x is greater than 6. And we're going to divide both sides by negative 2. Now what happens on inequality when we multiply or divide by a negative? We got to flip that symbol. So this is going to leave us with x is less than negative 3. All right, so we got those two. We're going to hop over here to our calculator, and we're going to see how we can graph when we just have an x and not a y using that inequalities app. All right, well, let's move over here to the calculator and graph our inequalities, both which is x is greater than or equal to 5, and then also after that we'll do x is less than negative 3. So let's go in and we're going to first go into y equals, and let's clear what we have. And then I'm going to scroll up here to where it says x equals. And I'm going to hit enter. All right, and so right now we've got x equals, and we want to change that to a greater than. So I'm going to hit alpha graph, which is F5, which should trigger the greater than or equal to. And there I see that. And we just got x is greater than or equal to 5. And so we should get a vertical line on our graph, and it should be shaded to the right of that of our vertical line. Let's see if that's true. Ah, yes, there we go. So we got x. There's x1, 2, 3, 4, 5, and there's our shading. Obviously, it'd be real easy to substitute 0 for x. Is 0 greater than or equal to 5? No, it's not. That's why this side over here is not shaded, but it's shaded greater than 5. All right, pretty cool. A little inequality apps allows us to graph in the form of x equals. So let's go back to y equals again. And we're going to move our cursor up to x equal. We're going to hit enter. And we're going to clear what we have. And this time we're wanting a less than. And so I'm going to choose alpha 2 or alpha window F2, and that should give us a less than. So alpha window. And that does in fact give us a less than, and this time we've got negative 3. And so we should have a vertical line where x is equal to -3. Hopefully that's going to be a dashed line, not a solid line, since it's just a less than and not a less than or equal to, and it should be shaded to the left. And there we go. There we see our dashed line where x is equal to -3. Everything is shaded to the left. Shazam! We have done it. Now, while we're here, let's go back into y equal. We're going to close this out. I'm just going to move my cursor up. Let's say I want to go in there and clear out that x equal. Let me clear that. And let me go back in here and take a look at what I've got. I may want to restore that. Let's hit alpha F1, get it back to equal. Now I'm going to move all the way up here to where it says quit app. I'm going to hit enter. And it says continue, or do I really want to quit? No, I really want to quit. I can pick it up later. I'm going to hit enter. And that's going to bring me back to my normal screen. And we are done.